You might think engineering is all about, you know, designing those incredible structures or coding really complex systems, maybe inventing the next big thing.
Right. The tangible stuff.
Exactly. But what if I told you the real cornerstone of a successful engineer isn't just solving those tough problems? It's about effectively communicating the solutions. That's the skill that, well, it elevates everything else they do.
That's a great point. It often gets overlooked.
So our deep dive today is into engineering communication, and we're drawing from some foundational engineering principles here.
Yeah, and our mission, really, is to give you a shortcut
A shortcut.
to understanding why clarity and structure are just so paramount in this field and how engineers actually get their work understood.
And crucially, how these ideas apply way beyond just engineering blueprints, right? Like to your own life.
Precisely. We're digging for those essential nuggets. It's not just what they communicate, but the huge impact of how they do it.
Okay, so let's unpack this a bit. Our sources, they kick off by saying engineers are fundamentally problem solvers. We know that.
Core identity.
But then they make this really powerful statement. Engineers must communicate their solutions effectively.
Must. Not should, but must.
Yeah. To all sorts of people inside their company, outside their company, it's not like an optional extra, it's baked in.
And what's really fascinating, I think, is the emphasis that the ability to articulate your solution is considered as important as the solution itself. Just think about that for a second.
Wow, okay.
Imagine spending, I don't know, months, maybe even years on some complex project, all that design, analysis, tweaking.
Right, countless hours.
But if you can't effectively convey the results or explain how you got there or what it all means,
Then what?
well, all that massive effort could just be misunderstood or misapplied, or maybe, worst of all, just completely unappreciated. The best solution is useless if no one gets it.
So it doesn't matter if you're an engineering student presenting some homework,
Right, starting early.
or a seasoned pro talking to the VP, or your colleagues, or maybe the sales team trying to sell your idea, or even the public.
Yeah, who might be affected by the project.
This communication thing is absolutely vital. It's like the bridge connecting a great idea to, the real world.
It really makes you wonder, doesn't it? How often have you seen a really brilliant idea or a clever fix just failed to get any traction? Not because the idea was bad, but just because it wasn't communicated clearly or persuasively, or maybe just in the right way for that audience.
Yeah, that happens all the time.
It just hammers home that in engineering, and honestly, probably in most jobs, it's not enough just to be right. You also have to be understood. And that understanding needs to be spot on.
Okay, so before we get into the how of communicating solutions,
Right.
our sources lay out these 4 basic steps to actually solve an engineering problem first.
Right, you need the foundation.
Seems like the bedrock. Yeah, you can't communicate a solution if you haven't actually found one properly.
Absolutely. And it's a really logical flow. Step 1, thoroughly defining the problem.
Okay.
Step 2, simplifying the problem, making reasonable assumptions.
Right.
3, performing the actual solution or analysis.
The calculation part.
Yeah, the heavy lifting. And then finally, step 4, verifying the results. Super important.
And each step isn't just about finding the number, is it? It's about building something solid you can explain.
Exactly. Building a robust, defensible solution that you can then communicate clearly.
Could you maybe walk us through the essence of each one, especially for someone who isn't an engineer who just thinks, well, you just solve it. How do these steps help with the communication later?
Sure, let's break them down. First, defining the problem. This is all about asking, okay, what exactly am I trying to do here, and what info do I actually have?
Like gathering clues.
Pretty much, yeah. Like a detective. The sources really stress that rushing this part is a huge mistake. Taking the time now saves massive headaches and, importantly, miscommunications down the line.
Okay, makes sense. Then simplifying.
Simplifying the problem. This is where you ask intelligently, can I make some reasonable assumptions to get a good enough solution without making this ridiculously complex?
Okay. Not just cutting corners.
No. It relies on really understanding the core principles. It's about finding the clearest path, which naturally makes the solution itself easier to explain later.
Gotcha. And then the actual solving.
Performing the solution or analysis, that's applying the principles, often with math. Now, here's a key insight from the sources. Set up the problem using variables first, like in symbolic or parametric form.
Variables, like X and Y.
Yeah, exactly. Before you plug in any specific numbers, think of it like A recipe, you write it with cups of flour, grams of sugar, before deciding if you're cooking for 2 people or 20.
Ah, I see. So you can change things easily.
Precisely. It makes the solution super adaptable. You can easily see how changing one thing affects the outcome. That makes your explanation much more insightful.
Okay. And the last step, verification.
Verifying the results. This
Yeah.
one's huge. Did I maybe misunderstand the problem? Were my assumptions actually sound? Does this answer even, make sense in the real world?
That leads to something that really jumped out at me in the sources, this line. There are no answer books outside the classroom.
Powerful, isn't it?
Yeah. And it strongly advises against just running to your boss asking, hey, did I get this right?
That is such a vital takeaway for you, the listener, no matter what field you're in. A good engineer has to develop their own ways to check their results reliably.
So it's about self-reliance.
Totally. It means building this internal habit of asking, does this feel right? Does it align with sort of my engineering intuition? Or if I tweak this variable in my symbolic setup, does the result change in a way that makes sense?
It's more than just checking the math then.
Oh, much more. It's about building critical thinking, building self-reliance, and building the confidence to actually stand by your work, all absolutely crucial if you want to communicate credibly.
Okay, so the engineer has meticulously solved the problem. They've verified it rigorously. Now comes that next big challenge, translating that complex solution so others can understand it.
Right, and act on it.
And that's where all these different written communication formats come in, starting with something maybe seemingly basic, like homework presentation.
Exactly. It might sound trivial, just homework, but it's actually the training ground.
How so?
Well, they often use engineering paper, which is specially formatted. But the real lesson isn't the paper itself. It's about training wheels for professional discipline. You have these distinct sections: given, find, solution.
So it forces a structure on your thinking.
Precisely. That structure, plus putting diagrams in one place, calculations in another, double underlining your answers, always stating the units.
Little detail.
They seem little, but they're not arbitrary rules. They train engineers right from the start to think and present their work in a way that's universally understandable and verifiable.
So someone else could follow your logic easily.
Exactly. It makes your thought process transparent, cuts down on ambiguity. You're building a solid, repeatable argument on paper.
Okay, moving beyond homework. What about in the professional world? We hear about executive summaries a lot. They seem geared towards a very specific audience.
Definitely. For the folks in top management, like a VP, the executive summary is absolutely key.
Why is that?
Because it has to be brief and concise, usually, no more than a few pages. Its only job is to summarize the most important findings or proposals.
The bottom line.
Exactly. VPs, CEOs, they need the crucial takeaways fast. They don't have time to get bogged down in every single detail. It's about respecting their time, making the impact crystal clear.
And then there are things like progress reports and short memos. They sound more like the day-to-day stuff.
They are the internal comms that keep projects chugging along. Progress reports tell stakeholders, here's what we've done, here's where we are. Often the format is dictated by management. Short memos are for quick info sharing, usually under 2 pages. Both are just examples of how engineers tailor their message for different internal groups, keeping everyone aligned without drowning them in information. It's about being efficient and targeted.
It really sounds like, whether it's homework or a memo, it's not just writing, it's communication designed for a purpose.
Yeah, if you connect this to the bigger picture for yourself, it really shows that communication is absolutely not one size fits all. Engineers have to meticulously tailor their message, not just the content, but critically who the audience is and what the communication needs to achieve.
Then we get to the detailed technical report. This sounds like the big one, the most comprehensive, maybe the most intimidating.
It kind of is. It's the ultimate proof of rigor and transparency, especially for experimental work.
How does it start?
It begins with a title,
Yeah.
obviously, and then a really critical abstract.
Abstract.
Yeah.
Why critical?
Because the abstract is often the first thing someone reads. Sometimes it's the only thing they read. So it absolutely must state the objective, the key findings, and the conclusions very concisely. It's like the gatekeeper. It decides if anyone invests the time to read your full report.
Okay, so the abstract is make or break. And then comes all the supporting detail.
Exactly. Then you get sections like explicit objectives, theory and analysis, laying out the principles, equations, assumptions, and apparatus and experimental procedures.
Listing all the gear and steps.
Yep, listing equipment, even down to model numbers sometimes, and the step-by-step method. Every detail is there to make the work replicable and verifiable by someone else. It's not just writing it down, it's building an irrefutable case.
The sources also seem to put a lot of weight on how you present the actual data within these reports.
Oh, absolutely. The data and results section has strict rules. Experimental results need to be in tables or graphs with absolute clarity, meaning meticulous titles, clear column or row headings, units stated everywhere, axes labeled properly on graphs, distinct data points. The source even specifies things like figure titles go below the figure, table titles go above the table.
Wow, that's specific.
Yes. And it's that kind of meticulous attention to detail, even title placement, that instills the precision engineers need. It prevents errors, ensures clarity, and builds professional credibility. No room for ambiguity.
And then to wrap it up, a discussion and conclusion.
Correct. The discussion is where you explain what the results mean, point out their significance, maybe compare them to theoretical predictions.
And conclusions.
Conclusions and recommendations tie it all back to the original objectives. Did we achieve what we set out to do? And based on that, what should happen next? Recommendations for action. And of course, a references section, properly formatted. It completes the story. Here's what we found, here's what it means, here's what to do.
Okay, let's shift gears from written words to spoken communication. The source covers oral communication and presentation. Now, we all talk every day, but doing a formal presentation, that feels like a whole different ballgame, doesn't it?
Oh, very different.
Yeah.
The main goal there is simple, but hard. Convey information in a manner easily understood by the listener, often under pressure, too.
And it has parallels to the written report.
Big time. It absolutely needs that same level of organization, a clear outline. There's a great piece of advice in the sources.
What's that?
It is harder to erase or correct what you say after you have said it than to write it down on a piece of paper and correct it before you say it.
Ooh, that's good. Hits home. You can't just backspace speech.
Exactly. It really drives home why preparation is so critical for oral presentations.
And they emphasize rehearsal, right, to avoid those moments you wish you could take back.
Absolutely. Rehearsal is key. Getting constructive feedback, maybe from a friend or colleague you trust. And really thinking about your audience, tailoring your language, avoiding jargon they won't know.
Makes sense.
The sources also suggest keeping talks relatively short, maybe about half an hour or less.
Why is that?
Because realistically, most people's attention span is around 20 to 30 minutes. If you have to go longer, the advice is to mix it up. Inject some humor or tell some interesting related story just to keep people engaged. It's about respecting their attention.
And visuals seem huge for presentations these days. Nobody wants just a talking head for 30 minutes.
Definitely not. Visual aids are massive. Engineers use software like PowerPoint, not just to show text, but to guide attention, to simplify complex data visually, and to seamlessly bring in charts, graphs, even video clips.
So it's more than just making slides look pretty.
Much more. The sources mention using attractive templates, sure, maybe your company logo for professionalism, but also using things like animation or slide transitions thoughtfully to enhance understanding, not just distract. These are tools for making the delivery clear, more persuasive, more impactful.
Okay. And what about this engineering graphical communication? That sounds like, well, a completely different language from writing or speaking.
It really is. It's a distinct language, and its power is in its precision, its universality. Engineers use these special kinds of drawings, called engineering drawings, to convey absolutely vital design information.
Like what kind of information?
Things like the precise shape of the product, its size, the type of material to use, the assembly steps. These aren't just pretty pictures, they are exact instructions.
Instructions for who?
For machinists who need to make the parts, or maybe they're how to assemble guides for really complex systems, or detailed wiring diagrams for electronics. Their clarity is everything mistakes here can be incredibly costly, even dangerous.
So like those really detailed circuit board layouts or maybe blueprints for a building, they have to be incredibly precise.
Exactly. Perfect examples. Total precision is required. The sources also mention engineering symbols and signs as another part of this language.
Like symbols on a schematic.
Yep. It's all about achieving that precision, that clarity, that universal understanding without needing pages of written text or long explanations. These symbols convey complex ideas quickly and unambiguously across different engineering disciplines, even across different countries.
Okay, so wrapping this all up, what does this mean for you, our listener, whether you're actually studying engineering or maybe you just want to communicate better in your own job or, daily life?
Well, I think what we've seen is that this ability to articulate your findings,
Hmm.
whether it's in a superstructured homework problem or a quick, punchy executive summary,
Mm-hmm.
or a compelling talk with great visuals, or those incredibly precise drawings, it's just fundamental. It's not an add-on.
Right.
It's all about carefully tailoring your message for your specific audience, making sure you're absolutely clear and always, always doing that verification step. Checking your work, thinking critically, does this actually make sense? That's what turns a good solution into one that actually has an impact.
It reminds me of that German proverb quoted in the text: "Who has never tasted what is bitter does not know what is sweet."
What do you mean?
Well, in this context, maybe if you haven't really struggled to communicate something complex, if you've never had a great idea fall flat because people didn't get it,
Ah, I see.
you might not fully appreciate just how powerful and impactful, clear, structured communication really is when you finally nail it.
That's a really good way to put it. And it prompts a final thought maybe for you to consider.
Okay.
How can you take this engineer's mindset, define, simplify, analyze, verify, and apply it, not just to technical stuff, but to how you approach and communicate challenges, ideas, solutions in your own life,
Hmm.
your own work?
Thinking about communication itself as an engineering problem almost.
Sort of, yeah. This week, maybe just note what you communicate
Hmm.
and ask yourself, could I make this clearer, more structured, more impactful for the specific person I'm talking to?